Good morning.
Good morning.
How are you doing?
I'm good. This is my second round of coffee.
Nice. I got one right here and I got one right here.
There we go. Double fisting it.
How's Kansas weather doing?
In weather roulette, it's very nice today. It's supposed to be maybe close to 90 degrees, even though it was snowing on Tuesday, because that's how it rolls around here. In fact, we thought someone was breaking into the house the other day, and it turned out it was just the wind. The wind blew my patio furniture a good 2 feet, like it was just dragging across the brick in the backyard. It's nuts.
That is nuts. That sounds like a win-win situation.
Yeah.
That's terrible. That's so terrible. But I'm glad that you weren't being robbed is what I mean. That's what I mean. Yeah. So thank you all for watching wherever you're coming in from. Let us know how you're doing. It's the weekend. I know some people are watching from around the world and it's evening there. So good evening to you. Our guest is not in our country. We have an international star with us today. Our good friend. Do you want to talk about him before we bring him up, Alice? Can you give him the introduction?
Yeah, for sure. Sunil and I are really good friends. He always cracks me up, and you can always count on him to be spicy. He's got comments and ideas and things to say, and he's not afraid to drop the F-bomb if needed. He is one of my favorite mathematicians and authors, and if you're not following him on Twitter and Facebook, you are completely missing out, and I'm super excited to have Sunil Singh joining us.
Yay.
There's my Tim Hortons coffee, being the good Canadian.
Tim Hortons Canadian.
Yes. And math recess. Yes. Nothing goes better than math recess and a cup of Timmy's.
There you go.
How are both of you?
That's right.
I'm tired.
Yeah, I'm tired. I know. Let me make a couple weather jokes because you talked about weather roulette.
Yeah, here's some weather jokes.
I live in Canada, right? So in Ontario, we have two seasons: winter and construction.
I'm too tired. I'm just gonna get lost.
I know. Yeah, even if you don't know what it means, it goes. That's got to be funny. Like
I get it.
And the other one is Winnipeg, which is in Manitoba. The joke about Winnipeg is that's where snowstorms go to die. I don't even know really what that could mean, but it just sounds like to be like we get the coldest of the cold, and even snowstorms can't survive our cold. I don't know, but it's funny.
Is it still cold there, Sunil? Because we're
nope,
finally.
Nope, and I will convert it for Fahrenheit for you Americans. It's about 60 degrees right now.
Wow, you're beating me.
Yeah, it's a bit above normal right now.
Nice.
Mine's 38, but it's supposed to be hot later today. It's 9 o'clock. I'm not sure.
You're hot.
My daughter's a fifth grader, and working with her on doing measurements with number lines. My students and my kids cannot understand or believe that we measure in 16ths. I know we just like to do things the hard way over here. Why boil water at 100? Let's go for 212. We just want to do everything that makes no sense over here.
Well, we didn't plan this, but this book was sitting here right on my desk. It's called Measurement. The Story of Measurement, actually. It's a really good book.
What makes it good? Well,
it's a story. It actually talks about just all the different ways we measure, why we needed to measure, of course, different units of measurements in different parts of the world, countries, civilizations. Even just think about, when we do measurement, with young children, maybe we should use things that they already kind of have, like how many thumbnails,
right?
Or how many dinky cars, or how many those erasers, whatever they have, use that to estimate the length of something, and then have them also go, okay, well, what's the length of, let's say, your book in terms of a paperclip. Well, what's the length of the hallway and the length of a paperclip? And some students are going to go, well, like that's not practical or whatever. So they get the idea of maybe units and proper sort of measurement tools through their own sort of, interests.
Mm-hmm.
That was a pop-up math idea.
Well, I feel like it's really important that we give kids conceptual understanding of numbers. And so starting off by just the concept of measurement and not saying, inches and centimeters and introducing the ruler there. And I believe that's a common core standard, right? Is measuring things in shoe lengths. I feel like that's what I battle right now, is just such a lack of number sense and understanding that you can convert from one thing to the other and it's the same. Even 1/2 to 0.5 challenges some of my high school students.
Well, I think, I mean, not to go down this rabbit hole, but part of the problem of all of that is that we don't spend enough time in whole numbers.
Mm.
Okay. I just happen to have another great book by Edmund Harris, Hello Numbers, What Can You Do? And Edmund Harris actually teaches calculus in Kansas. I forget which college, university, I'll have to remember. But he decided to write a book about numbers 1 to 10 and how they actually communicate with each other.
Mm.
So I think a lot of our issues with fractions and all that comes because we haven't spent enough time with whole numbers and their interplay of just number sense and fluency and flexibility to the point where it's like muscle memory.
Right.
Like you may not get the right answer. Like if someone goes 8 times 7 doesn't give me the right answer, that's not a huge concern. What's more interesting is if someone goes, okay, 8 times 7, I know what 10 times 7 is. Like if you start talking like that, that to me is more interesting.
Definitely more interesting. One is
the
here's something approaching with a strategy. That's probably my number one word that I use in teaching math is what's your strategy? Thinking about it more along those lines. All right. Speaking of conversion, are you preferable to degrees or radians?
Probably degrees now. Radians at some point. I mean, I understand the historical significance of both. I mean, radians but then we start getting into discussion about Pi Day and Tau Day, and that we should be celebrating June 28th. Tau is 6.28 because that's like one whole revolution of a circle. 2 pi. Pi is only half. Right?
Yeah, I was teaching my students this week. Just remember, it's only half.
It's only half, right? So it's a really odd thing to think about. Where should we be thinking about the whole circle? So I'm more a proponent of not like this or that. Well, how about both? Let's just share both ideas.
So, Melody, you can measure temperature in degrees Celsius or degrees Fahrenheit, right? And it's just a different conversion. Do you measure in centimeters? Do you measure in inches? So do you measure angles in degrees or radians? So I think we typically think of 30 degrees. If you were to convert that to radians, it is 1 radian is the angle where the radius is the same as the arc length. Wrap your brain around that one.
Well, to be honest with you, I thought we were talking about weather still, so I just realized we were. It's like,
that's okay. We can still, we can talk about absolute zero. That's actually we'll go down the rabbit hole of negative numbers and how zero was supposed to be the lowest number. So we'll leave that for another day.
Is it in your book?
All right, Mr. Rucker. Yes, I feel like that was a natural segue.
It was a natural segue.
If there ever was. Tell us about your new and wonderful book coming up, Chasing Rabbits, A Curious Guide to a Lifetime of Mathematical Wellness. Tell us about
nice to hear the whole title from somebody else because I've said it too often to myself. So it's nice to hear someone else say it now. I finished it. I mean, when I finished it, last February, just over a month and a half ago. And I know I finished it because I was okay to let it go. I didn't find myself going back in the Google documents and making like, oh, let me update this, let me update this, let me update this. I let it go, and now we'll go through the editorial process. But we were talking before we went on sort of air, the cover design should be done next week, and I was about to answer it, but then I said let's save it for our sort of coffee chat when we're live. So there's a couple things about the cover which are tied to the title. So chasing. It's not the chasing that we think. Like chasing, like if you look at where chasing comes from, especially from Alice in Wonderland, the rabbit, is the sort of frenetic thing going, I'm late, and Alice is chasing. No, that chasing is actually just means following, and you're supposed to move, especially with mathematics, at a leisurely Sunday stroll. So on the cover, Alice will not be running, and neither will be the rabbit. And the rabbit will be in the far off distance, and where Alice is, it will be illuminated in a forest with color, and where the rabbit is in the distance, it'll be bright light, symbolizing there's more to come. There's always more to come. Never, ever, ever, ever stop moving in anything, but especially if you are a math educator. That to me is the symbolic idea that you are always in the moment, and there's always just as much ahead of you as was behind you. And the wellness part comes from that's where the wellness lies, is that, one, to be in the moment, and to be in the moment of not necessarily understanding, to be in the moment of whatever your natural emotions are, which goes back to the students in our classroom. If we want true equity, then we have to honor all the responses, emotional responses to a math problem, not just the joy and wonder. Of course, we love that, but we also need confusion. We also need a little bit of humor, anger, like all the emotions. Like, why are we doing that? Well, who would have 30 watermelons? Like, you would never do that. You have to allow those expressions
ridiculous.
in. If you don't allow those expressions in, it's like the editing process. It's like you're in love with what you already wrote. Well, someone's going to come back with you and go, that's not a practical problem. And if you address that in a very kind of, you know what, you're right, then that student feels validated, and then maybe they will express a different emotion next time, right? So they won't be locked into these cliche, like, I'm the confused kid or I'm the joy kid. No, all those emotions are actually very important in learning mathematics. And that's kind of one idea of the wellness piece, is that whatever your reaction to math is at that moment in time, it may not be the one I know we want all our kids to understand, but for me, that's like the finish line. And whether we want to get there, but most of mathematics has been about slow failure. Most of mathematics has been about a confused state of mind. And if I could say my F-bomb, most of mathematics has been about as being confused as all fuck. Like that's the bottom line. So our students who are confused, they're the natural mathematicians.
Yeah.
There's the spice, ladies and gentlemen.
There's a spice. There's a bit of like rum in your coffee this morning. Maybe not.
I thought that was just me. I was going to ask how you guys took your coffee, but hey,
Only around maybe like the holidays, it's like, but no, I wouldn't make it a habit. Unless I was maybe camping or something like that, campfire,
Never
waking up.
my coffee. I'm missing something here.
So yeah, that's kind of one micro idea of it, but the wellness piece is really important because it's very similar to what we think of wellness, right? I mean, it's something which is a very holistic, long-term idea for our health. And right now, for many kids, it's the exact opposite. Math is anxiety. Math is like low self-esteem and all these things. So this book is really a journey to talk about, well, what does even wellness mean? How do we get there? Are we already here? So it's kind of like I'm talking to you. I write in a very conversational way. It's the only way I know. Like we only have one voice. I don't have an academic voice. I don't have it's it's the same voice I have.
It's a good voice. I agree with everything you're saying.
We all take our call at the same time, too.
No. So how much longer do you have for this semester, Sunil?
For my kids, or I only teach. I teach at Dexter Learning. I teach a 6th grade class Monday to Friday. It's only a 30-minute stream, and I was asked to do that last year because I've been out of the classroom since 2013. But this is actually my favorite part of the day is teaching. I actually teach it twice. Once for kids who are actually on campus in Wichita Falls, Texas, at Dexter, and then remote kids. And I actually have a kid who's in 4th grade and one in 5th grade. And I think I found my calling. I mean, I taught high school my entire life. But boy, oh boy, like I look forward to those kids, especially the remote. They like half the kids turn on their screens. So it's not a black screen.
Mm-hmm.
I can see their faces. It is like math recess where it's like, every time we end in chat, it's all buys with 3 exclamation marks, thank you and all that. Like that's the best feeling in the world. Like these kids have really enjoyed being together. That's the important part too. They support each other in chat. And that's their own organic kind of thing. I don't legislate going, okay, we got it. No. They've realized that the best way to learn math is in a very collaborative and communal way. Right.
That's awesome. I mean, when teaching my own kids, part of that was to help them to understand math and get that math sense. But I just feel like it's happening. It's happening really. Sometimes it happens and it feels really like slow moving work, especially with my oldest two, to kind of deprogram a lot of what they knew.
How old are they?
When they were in the school system, but there's just so much like, why in the 2nd grade did my daughter love multiplication and could spit out facts, but now it's like her working memory is so exhausted whenever, like she just gets so anxious. And my son, I mean, he's doing much better. You guys would be so proud. We were doing prime factorization the other day, and I felt like this was a moment for both of you. So I saved it. We've been working on prime factorization for the last 2 days. And I was telling my daughter, like, this is really fun. Don't you think? Like, this feels like a puzzle. We're just solving these puzzles. She's like, yeah. And in my mind, I thought, let's just do this for a while. I mean, how many things is she reviewing? She's reviewing multiplication. She's reviewing, like primes, and reviewing, like, how many different objectives are we practicing while we're going here? Everything across the board. And I don't want to just move on. I want to stay here. I want her to enjoy it. And then we'll go to the next piece. And I'm throwing in some confusion there. I'm making her check her answers. We're going through all of it, but it's not such a battle. And that's a win this week. That's a win to win this week.
Well, it is. And I like the idea that, when you use like one type of math idea, like prime factorization, like you mentioned, you've got so many other things happening at the same time. And it goes back, unfortunately, sadly, ironically, I've said this many times, but unfortunately, I'm going to keep saying it until there's some sort of change. Kids don't hate math because it's hard. They hate math because it's boring. Right. And we tend to translate that, well, they're having difficulty here. Yeah, but they could be having difficulty because what you're sharing with them is just boring. Like I know there's certain things that you might have to cover in a curriculum. I get that, but I'm going to tell you right now, because I've taught the middle school kids. I've even gone into my daughter's class when she was in grades 1 and 2. Kids are, first of all, young kids are very resilient. Okay, yeah, there. You could have a kid who gets a answer wrong 16 times in a row, but in grade 1 they're going to have their hand up again. They want to participate. So what I've found is that the sweet spot is to actually have a math problem or idea just a little outside their academic maturity. Like, so it's like, because then it's like even for everybody, everyone doesn't know what's going on. You want to have the right amount of, okay, I get it, but I don't know what's going on. Like that, to me, it's like cooking. It's like
a gamification principle. So
yeah, it is. It's exactly the same thing. And And so, Melody, you're talking about the prime factorization with your kids. So I did this for 2 weeks. I wrote a blog about it. So Albert's Insomnia, the game with the cards where you have to, create using PEDMAS, whatever you call it, with these cards which are dealt. And so I had dealt these cards a couple years ago, and something amazing happened. So I put out the cards 3, 4, 7, and 12. And I told kids we're going to create sort of PEDMAS questions to get the answers 1, 2, 3, 4, 5.
Yeah.
The only rules are you can only use each card only exactly once, so you can't use a 3 twice. If the card is there, you can point to it. So if you need to make a 4, 4, but that's going to exhaust itself after a couple of times. Adding, subtracting, multiplying, dividing. So, but I also said, I'm going to teach you some, and this is Berkeley Everett from California came up with this. I'm also going to teach you some power-ups, right? So staying with gamification. So I taught these kids like, okay, factorial. So 4 factorial is 4 times 3 times 2 times 1. Just take the number I say and multiply all the way down to 1. So after a while, none of these kids knew what factorial was, but as we got like 3 days in the game, 4 factorial is 24, 3 factorial is 6, 5 factorial is 120. Those became math facts. Like they become like old hat. I taught kids exponents and square roots because the square root of 4 is 2. So if we ever needed 2, square root of 4 is 2.
Yes.
So what happened was we played this game for 2 weeks. We finished at 199, and there's only about 8 to 10% of the numbers we just couldn't get. And Serafina, who's in 5th grade, who didn't know what factorial was when we started, when we got into the 150s, 160s, she created a math fact using just a 3 and a 4 of 180. She did 3 double factorial. So she wrote 3 factorial, which is 6, then another factorial, 6 factorial. So that now becomes 6 times 5 times 3 times 2 times 1, which is 720. And then 720 divided by 4 is 180. So she realized we needed a math anchor in those numbers with just 2. And she did that on her own. And 2 weeks ago, she didn't know what factorial was.
So Melody, let's say that we were.
Oh no, but if you get, sorry, go ahead.
When you said, okay, so I followed this part that Alice just put down. I followed that.
Yeah.
But then you went on more, and I'm like, okay, then you lost me. So go ahead.
When we were getting high up in the numbers, and remember the numbers are 3, 4, 7, 12. So I told kids we always are using anchor numbers to get a lot of the answers. 4 factorial was used in the 20s and 30s because of 24. You can create a 24 with just 4 factorial, and then you still got the 3, 7, and 12 left to get other numbers around 24. So 4 factorial got used a lot, then we left it, and then we got into maybe 4 to the exponent 3, which is 64. That became an anchor number. So kids realized we started needing anchor numbers in every sort of chunk. And as we started sort of escape velocity from the highest numbers we could create, Serafina was going, we need an anchor number around here. I go, you're right, we do. So she created 180, and how she did that was 3 double factorial, because 3 factorial is 3 times 2 times 1. So that's 6. Now you still have another exclamation mark for factorial sign. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. And then 720 divided by 4 gave us the 180. And we kept using 3 double factorial divided by 4 probably at least 6, 7 times. And that became a math fact. Kids knew now that 3 double factorial is 720.
So are you multiplying? Are those little asterisks multiplying?
They're multiplication.
Yeah.
Okay.
So if I put in, I'll put into chat. Did it go to private chat or?
Yeah, I got it.
Okay. So 3 factorial is 3 times 2 times 1, which is going to give you 6.
Right.
But you still have another factorial because Serafina put 2 factorial. So after we finished the first factorial and we got 6, there was another factorial sign waiting outside, which meant we had to go 6 times 5 times 4 times 3 times 2 times 1, which is 720. So now 6 factorial became a fact. And that came from 3 double factorial, which was a legal thing to do in our game. And that was created by her. It wasn't my prompting. And this is what the game, kids had to get creative with the numbers. They had to get more elastic with it. And this happened very organically. And
I like that.
And it goes back to what I said. Kids have to spend more time with whole numbers and operations to have that sense of confidence, of creativity, and flexibility. It just can't be, oh, guess what? We're going to spend the next 3 days doing number sense and flexibility, and then we're going to go on to decimals and fractions. It doesn't fucking work like that.
Hello. There's the spicy.
There we go.
I agree. I'm going to drink to that.
There you go. Cheers.
No.
People, somewhere out there just spit out their coffee.
I've met a new friend, and the funny thing is that I met her because my son broke her son's arm. And so she messaged me and says, your son broke my son's arm. And I'm like, well, I'm sorry to hear that. I apologize a lot more than that. But I hope we can be friends. So now we hang out all of the time, and we've bonded over this, and she still lets my kid play with her kid. But I try to convince her every time we get together that, of course, she's good at math. And somehow we end up 9, 10 o'clock at night doing math problems together. I'm the best friend to have. You come over and hang out with me. We'll do math. But math is so interesting, and it makes you feel good, and it feels good to think and to get things right. And so woe to anyone who says I'm not good at math. Is like, whoa. You're not good at memorizing facts you don't understand. Of course you're good at math. And it's interesting
when you say good at math. So I took a little liberty and I changed the preposition to make it a little bit more holistic. I said, maybe instead of being good at math, I think it's more important to be good with math. And what I mean like that, like good with somebody, like, are you okay with math? Because math sometimes is going to be very tricky. If I could sort of personify it, math is going to be kind of like this sort of, whimsical person. Math is going to be very moody. Okay. So are you good with he and him or they? Like, be good with it, because it'll take you down a really cool road, but you're going to have some ups and downs. You may not like it at times, but just be chill with math. Just be chill, because in time, they will become one of your best friends. And when I'm not selling that, overselling that. I think a bit of both, but like, if it wasn't for mathematics, like, mathematics is a huge part of my personality, which means it has illuminated so much in my life. It makes me a better person, which makes me a better friend, makes me a better father.
Yeah.
It's not about, oh, you'll be able to count change when you go to the grocery store. You'll be able to balance your budget. Those are all important things, but that's not what puts a smile on my face, or like, that's not what makes me happy about mathematics.
No.
Right?
No, cleverly figuring something out. So I have a student who I have been working with, and I've just been pulling up open middle, and I told him, look, we're going to do third grade. He's a high school senior, but we're going to do like third grade, and not because you don't know third grade math, but because we don't teach math this way. So we go to open middle, and we just look, I let him pick any problem he wants. I go, what I'm trying to teach you is how to strategize and how to think through. So let me go ahead and share my screen.
Yeah.
This is what I did yesterday with him. We actually did several of them, but this is one of them that we did. So you have a 3-digit number plus a 3-digit number plus a 3-digit number, and you can only use the digits 1 through 9.
Got it.
Okay, so I'm going to go ahead and duplicate this. Let me give you edit access. I'm going to share this so anyone with the link can edit. Editor, copy the link. So if you guys want to jump in, I know you're excited about it. And let me make a few more pages so that we have lots of room. So my first rule when I talk with them is, you're not able to get these right on the first try. It should take you a minimum, no matter what problem we do, even if it's for third grade, should take you at least 5 tries. And the goal is not to be like, hey, I was able to get this in 2 tries. That's actually disappointing. I did one of these open middle problems, and it took me 60 tries to get it.
Oh yeah.
And I did a similar one where it was discount and tax. So one is minus and one is plus. Otherwise, it's the same formula. And so I started with my answer to discount. So when I went to go do the tax, I ended up having, it only took me 2 times. And it took me 60 times to get the first one, only 2 times to get the other one. And it just like felt deflating. Like, oh, I got it right. Like I came to the answer too quickly. What's fun is that I had to struggle through it and strategize and figure it out. And so we were having a good time doing this. So your very first strategy when you do these is to pick any numbers, right? I don't even necessarily think on this. I'm trying to get as close to, let's say 200, supposed to be 1,000, as close. Yeah, that would not work very well. As close to 1,000. The target number is 1,000. So who can get closer to 1,000, right? So the first thing I'm going to do is 987, 654, and 321. And adding those up, that's obviously way more than 1,000. I don't need to add that because I've got almost 1,000 right in this one thing. So what we're looking for is not so much the answer is, okay, well, how would you strategize? What would you change on this to get it closer to 1,000? So knowing that I've got 3 groups, if I have all of them similarly close to 300, it's evenly spaced, that might be my strategy. And so what do you want to trade? So that's what I ask them, right? Let's just put whatever numbers you want, put the numbers down, and then let's leave what you have and let's strategize. This is way too big. And so what happens if I just trade the 9 and the 3? Well, this becomes a place value conversation. Switching the hundreds place won't make any difference. Right. So what ways that I can get this number down? So, all right. So you guys.
Do you want me to actually say something?
Yeah, go ahead.
I wasn't sure if you were. Yeah, like in my mind, I'm thinking that we would just start with the lower numbers for each. Like it would be 200, 300, and maybe 400.
Yep.
200. Would you say 300 and 400?
Yeah.
Okay. So this is Melody's strategy. She starts with the hundreds place.
And I want to put the bigger numbers.
Right. Then what do you want?
2. I want to put the 9 and the 8 with the 2. Oh, I don't even know. Maybe that's not right.
Okay.
So, but I'm just starting here.
I'm just starting. Right. Exactly. All right. So then you've got a 1, a 7, a 6.
Right. So I'll put 6 and 5 with the 3 and 2. No, I already used 2. 1 and 0. Oh, shoot. There's no 0. What number am I missing? 7 and 7. Yeah.
Okay. So let's use a calculator here.
Yeah.
Although I would strategize when I do it in my head, but since
right. I would do a lot of estimating right now. I can already tell you.
All right,
and when I'm explaining,
look how close you are.
Holy shit!
That's really good.
Look how close you are.
Okay. Whoa!
So
and then I would say I'm 80 off. So where could I offset that 80? This is where I would go.
Okay, let's switch. So what do you want to do? It is fun. See, strategizing is fun. Regurgitating, not so much.
Okay, it looks like I want to be lower on the 400. And Sunil, throw in. I feel like I'm not. I could use.
No, I would have started the same strategy. Work on the hundreds and just try to use 2, 3, and 4 to be. You're going to be in the ballpark, obviously, because. But I mean, I would have started with the same strategy. 2, 3, 4. Let's tweak it. I'm thinking of the 9 as a potential 100 because it's so close to it. So I'm almost thinking like that goes, with the 2. So it's the same strategy. And now that I'm, the only thing as another strategy would I have, I'm not saying it's going to get it to us, would be like, okay, well, what's the average? It's 333.
Ooh.
Okay.
You already figured the average out?
Yeah, I mean, that's my first thing I go to because I know that I have these 3 boxes and it has got to add to 1,000. So the average of has to be 333.
more specifically, Melody, 1,000 divided by 3 is about 333. So if you do a lot of math, you know that 1/3, the decimal approximation for 1/3 is 0.33333. So as someone who does a lot of math, you see this pattern often, that 333 for a third is kind of one of you just know, like 1/4
calculators is coming.
Yeah, it's not magic that he's just has number sense around that.
And this goes back to the whole, like, I mean, so if I put if I'm thinking 333.3 is the average, then the numbers which I might actually consider for my hundreds just as a first go might be 135. And then I know I'll make.
All right, so you're going to do 1, 3, and 5 your strategy.
And let's see. Then I'm going to put 24 and 5.
Oh, 24 over here?
Yeah.
Okay.
And then I'm going to put 46 in the 346.
You've already used 4.
Oh, so 367.
Okay, 367.
And then 189.
Okay. All right. And for the sake of time, and because I can't do math when people are watching me.
I know. I'm doing it too. 3.
Okay, you ready for this? You ready for the big reveal?
Okay.
You ready? You and Melody got exactly the same.
Nice.
I love this.
That's fun. Look how much fun we're having. I did a Desmos polygraph activity with my students. I haven't used the polygraph activity before. And so I just picked up one on quadrilaterals. And so what it does, it gives them a bunch of pictures of different quadrilaterals, and a quadrilateral is a 4-sided figure. So they might look like a rectangle, or it might actually, some of them look like a check mark kind of thing. So it's just like a whole bunch of quadrilaterals, 4-sided figures. And then Desmos automatically pairs them up. So they have working with different students in the room. And what they do is they ask questions like, is your quadrilateral, is it skinny? Does your quadrilateral have parallel sides? Does your quadrilateral have 90-degree angles? So they can only ask yes or no questions, and they have a whole grid. So then they're like, okay, it's not these. So they remove the ones based on the yes or no questions, and they try to guess which of the first partner picks one of them. The second partner has to guess which one they picked through yes or no questions. And so I have not had this level of engagement with my students for a really long time. So they had a work day, which is always dangerous because some of them will work and many of them think that means it's free time. So I said, you can work on your project. If you're done with your project, once you do this polynomial, and I had students working on it the whole time. They were laughing. They were like, you can't use that as a question. What do you mean? What's a small quadrilateral? You can't have a small quadrilateral. And it's just like the conversation. And I literally said nothing. All I said was, I want you to play this polygraph activity in Desmos. And so that thinking through and just figuring out how to describe these pictures was really engaging for kids.
So, Alice, while you're there, I want you to draw any funky looking quadrilateral.
Okay.
So draw like, not a convex one like the last one, but draw like a quadrilateral. Make sure like not any of the sides are the same length. Just draw any weird looking quadrilateral, which, just draw it.
Okay, this is not a trapezoid.
No, just draw any 4-sided shape.
Okay, I got one.
Okay.
I want to tell Miss Rocky, there is a video about this, Miss Rocky. It's in Alice's YouTube. She's been talking about open middles for a little bit, and I'll try to find that link while they're going through this convex stuff.
So what I want you to do now, and just eyeball it, locate the middle of each side.
Okay.
Okay. Good. And it probably would have turned out better if you'd exaggerated the size, but it's still going to work.
Yeah, I can
now join those 4 midpoints.
Join the 4 midpoints, okay. Yeah. Okay, here's a little trick. If you hold down the shift key.
Yes, you get a straight line.
In Jamboard, it actually makes straight lines.
So you're always going to get a parallelogram. You'll always get a parallelogram if you do that with any four-sided quadrilateral. And then you can start to ask kids questions like, why does that happen?
Yeah, why?
Yeah.
So what is your favorite thing to teach, Sunil?
It goes back to history. It goes back to, it's got a whole branch of mathematics, number theory. The curiosity of numbers starts with numbers. So for example, since you got the Jamboard,
let's do it.
write a 3, write a big 3.
Okay. Come here. Okay, I'm gonna write a big 3.
Okay.
Is that big enough?
And then put 2 in the exponent. Yeah. Okay. So when I again going back to, I like to teach things which are just outside of the realm of kids. Like I would actually show that to kids in maybe 2nd or 3rd grade. Once they've just learned multiplying, I'd go, okay, can someone read off this number? So maybe one kid might go 32, nothing wrong with that. Another kid might go, why'd you make the 2 small, right? All these goofy questions, which I think are great. And I go, nope, it's not 32. Yes, it's kind of goofy, but who knows what 3 times 3 is? And of course, half the hands go up. They go, it's 9. Well, this is another way to write 3 times 3. So now I'm introducing exponents. And what I do actually, what I did with my Math Recess kids, so now write 3, but the 2 on the other side. So on the left side, so it's in the left upper script, not the right upper script. Yeah. So very few people know what that number is because everyone thinks we stop at, addition, multiplication, and the train gets off at exponentiation, which is 3 to the exponent 2. No, it actually keeps going. If you keep going counterclockwise, that means tetration. And what that means is if exponentiation is making 2 copies of 3 multiplied, tetration means 2 copies of 3 as exponents. So that actually means 3 to the exponent 3. So that's another way to write 27. And again, you give this, you'll give it to high school kids. You're wasting it on high school kids. You give it to kids who are going, oh, I'm going to tell my mom, dad that. They don't know that. Like that's why the title of my book, you're chasing rabbits all the time. It's that curiosity. That's the most important thing. I always make sure the kids leave my math stream like, yeah, they want more. They want more. It's not like, okay, I'm good. I can leave the mathematical table. I'm going to play jacks or I'm going to go for a bike ride, which are also important. But you want kids to come back the next day going, okay, give me more of that. Give me more of that good stuff. That's why, going back to your question, Alice, and even the stuff you just did now, the open middle problem, like that to me builds that fluency and curiosity for numbers. What's the interplay with them? And the stronger their interplay, the stronger their confidence, the stronger their sense of flexibility and creating their own sort of 3 double factorial, the rest will take care of itself. It will. Because they'll have the strong arithmetic, which builds strong algebra.
Right. I just made an open middle problem yesterday. So I told you I was going through open middle. Good.
And I just found your blog post. I dropped it in the comments. So Miss Rocky, if you're seeing this, I dropped that in for you.
Oh, we were just picking up random 3rd grade open middle problems, and I noticed under geometry there were zero 3rd grade math problems. I thought I made it in this account. I guess I made it in a different account, which is why I can't find it. Hold on, I'm gonna get it. You guys talk amongst yourselves for a minute.
Okay.
I don't know. That's dangerous.
Can I share my screen? Can I share my screen?
Yeah,
please.
Yeah. Do you see the share button?
Yes, I do see the share button, and I've got permission too.
Yeah.
Awesome. I love getting permission. This is this was the last blog I wrote, which was talking about that game, Albert's Insomnia, 2 weeks through the looking glass, a journey of student creativity, curiosity, and collectivism. And it was simply about playing, with 3, 4, 7, and 12. And I'll put the link to the blog in as well. But everything you see, that's the students' work. I was just recording answers. So look at what happened between 111 and 120. We use 12 take away 7, which is 5. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 120 became our anchor number all the way from 111, including 120, because 3 and 4 are small, and kids figured out how to make the numbers 1 to 9 with just 3 and 4 different ways. And then they had the aha moment saying, guess what? The other side of the hill, we simply add those numbers we created. So 120 became, we whizzed through 111 to 130 in about 3 minutes as a class. And then this is there's the smiley face. That's 161. That was the first time we introduced 180, Serafina, to get 161. This and that scribbling stuff, that's all good. That messiness, that imperfection, that's all. I always love to show all the messy work. Okay, that to me, it shows the humanness of mathematics. I'm not going to be perfect. Here it is. This is the raw stuff which I was circling, and what I was doing was I was circling prime numbers also. So kids realize that prime numbers are tough to get because we need 2 numbers to multiply, and the only numbers are 1 in itself. So they become the more problematic numbers. So kids are learning about primes as we march to 199. Okay, so let me stop
I'd like
there.
to say something salacious. I don't like kids to use pencil. What I was working with yesterday, he kept erasing. I'm like, no, that's not the point here. It's supposed to take you 5 times. We want to this is your strategy. It's not wrong. It's your attempt, right? And then we're going to put something and we're going to think about it. How might I adjust it? And if I adjust it and it's worse, that you didn't do it wrong, that's beautiful, because then you're self-correcting, you're getting feedback, and you're making adjustments.
No, I think that I work in pen. I think I stopped working in pencil. I mean, what I like about pencil, staying with that, I like seeing eraser marks because that kind of has that sort of residue of something you just did, and now you're updating yourself. But I like the idea of pen and show everything because that's going to document your journey through this one particular problem. Don't discard the stuff. It helped got you to where you're going to go. Give it props, give your mistakes props.
So let me show this in Google Slides. I was at an airport and someone had tweeted out, hey, does anyone know how to do this? It was for 7th graders and we don't understand how to get the solution. And then so they tweeted it out, and then I saw the most wonderful thing happen, Sunil. All of these rock star math teachers on Twitter got it wrong. Because mathematics is the journey of thinking. So I just held my finger on the tweet, copied the image, put it into slides. I'm literally in the TSA line working on this. So my first thing is, just brain dump out, what are all the things you might use, whether or not you do use it. And I go through here and I'm demonstrating okay, well, I'm thinking I need to add back the intersection. My first stuff to do is not to do a math problem, but rather just think about what I might need to think about. And so I teach the students that we want to write those things down. Then I calculate something, whether or not I think that it's what I need to do. I just do something. It's not wrong to calculate something you didn't need. You might need it. Sometimes it just helps you to center in because you feel like you're making some progress rather than sitting there saying, I don't know. And one of my rules is you should Google something. That should be part of your process. I was at Stanford with Joe Bowler and Professor Keith Devlin, whose job title is mathematician. And he says the first thing he does when he solves a math problem is he does not get a pencil. His first thing he does is he Googles it. The second thing he does is he looks up YouTube. These are the steps and processes of an actual mathematician at Stanford. Let's embrace this. Okay, let's look up something. How might I use that? How might I apply it? So I get an answer, but I realize this doesn't make sense. And so you can see here through using Google Slides is I'm thinking through the process and I leave my mistakes, and they're not mistakes. They're elements along the journey that we all do, but we make kids think that we don't. We erase that, we omit the parts that we don't get wrong, and we make them think they're supposed to do it flawlessly, which I think it does them a big disservice. So actually, I ended up at the bar at the airport because I'd gone through TSA, and I had like everybody at the bar doing this math problem with me. So this woman and I were working it out on napkins, and we finally figured this out. So anyway, to your point. So I noticed that there are zero open middle math problems for geometry standards. So there's my challenge to you, Sunil, trying to submit some problems for open middle under geometry. And so This is the standard. And so I'd like you to criticize what I came up with. I think it's DOK4 to make the problems in the first place. It's a challenge. The standard is understand that shapes in different categories, for example, rhombuses, rectangles, and others may share attributes like having four sides, that the shared attributes can define a larger category like quadrilaterals, and recognize that rhombuses, rectangles, and squares are as examples of quadrilaterals, and draw examples of quadrilaterals that do not belong in any of these subcategories. So I realized I was trying to see how I could do use the digits 1 through 9 idea, and I feel very strongly that open middle problems don't have to be that way. But nonetheless, I gave up on that. And so I finally settled on this. I have got, let me drag this over, irregular quadrilateral, rectangle, trapezoid, square, kite, parallelogram, and rhombus. What is the relationship between them? So you can use these at most once. So a parallelogram. So my first strategy when I do open middle is always just fill it in the boxes, right? Just do
exactly.
Right? I'm not even thinking here. I'm just going to put some in. And then, of course, I want the kids to explain it. And what I love about Google Slides and Jamboard is you duplicate. So I don't want to delete my attempt. I want to see all of your attempts. All right, so parallelogram is a rhombus. Is a parallel, but not a rectangle. Is that true? No, right? Because a parallelogram and a rectangle is a parallelogram. They're not necessarily. And what I like about this is the directionality, right? A rose is a flower, but a flower is not necessarily a rose. So, like what if I switch these? A rectangle is a rhombus. Does that fit the definition? And so when I realized, no, it doesn't, before I adjust it, I want to duplicate it. I love Google Slides. And give a reason as to, okay, that didn't work. So I'm going to adjust my strategy. What do you think of my attempt? Of the problem. This is it. This is what I want to submit to open middle.
I like it. I like it because you can just put everything in and then just keep rearranging it. And even if you don't get it entirely right, those half-truths are also important. It's along the way. Like, the best part about mathematics lies between the question and the answer. Like, honestly, like I don't care what 1001 take away 783 is. I don't care at all. But how would you do that question the most efficiently? What is there stuff that you can take that you might be able to apply it later on? Unless you're dealing with the answer being 0, undefined, infinity, or some sort of application number based on some sort of constraint because it's an optimization problem, the answer in mathematics means dog shit. Where do two lines meet? I don't care where they meet. I just know the slopes are different. They're going to meet somewhere. So do I care that it meets at 2, -7? No. I'm interested in, there's algebra that could help me get the answer. So we focus so much on the answer. We focus so much on computation, long division. Like we were doing long division when, during the Little House on the Prairie era.
Exactly.
240 divided by 17. Get my phone out. Why? What's wrong? What did I do? No, we want you long division. Why? Tell me why.
Why?
Is there a purpose? If you're going to teach kids the algorithm of what's happening, sure, I'm all with you. I'll sit in the front row. But if it's simply to get the answer, then you're in a one-room schoolhouse.
Yes. I rant about this all of the time.
I call it wrong division. I don't even call it long division. I call it wrong division. It's like
you just, except you're not, like, that's the whole thing though. It's like we're still doing it. We're not in a one-room classroom.
No, Melody, that's what makes it even farcical. It's like that episode of The Simpsons where they had to pretend to live back in the 1800s. So we have a modern family trying to replicate that. We are like modern. Hey, let's pretend what it was like to live with when you had a slate and chalk.
I want to ask you two something, and it's fine. So I did the math struggle, but I like math. Like you said earlier, I'm chill with math. Like I can figure things out, and I know I can figure things out because I can see patterns and I can eventually get there, and I'm okay with getting it wrong. But I don't see math the same way you two do. And I'm just curious, like, how did that happen? How do people see math like you do? Because I know both of you are going to say that anybody could do it, but I'm just curious, like, well, then how did you guys do it? Because I succeeded in math through school. I mean, it was a struggle, but I loved it, and I tell my kids all the time, like, it didn't come easy for me, but that's how I figured it out, What about you two? How do you see math like this? How are you so in love with it? What the heck?
Well, first of all, I would make sure that you continue to see it through your eyes. And I'm not saying don't worry about how we see it, but it's your journey. And I know that what the intention of the question is, well, how did you see it? So there's a word I came across a couple of years ago and I use it all the time. It's called Quadrilateral, purposeful movement in no particular direction. So because of cotawampling, if I could use that in a word phrasing like that, I don't really have memory of how I got here. I don't, because part of cotawample is to unpredict your journey. So that to me is the exciting part. I'm excited about, I don't know where things will take me. So I can't trace all the breadcrumbs back, but I know that a lot of it lies in its lore. A lot of it lies in its history. A lot of it lies in its. So when I went back, when I was in 8th grade, maybe this is one example of where things might have gone for me to see math this way. We had a contest when I was in 8th grade that you would get 1 hour to answer these 30 questions. And how you would be scored would be the number of questions you got right divided by how fast you turned it in. So I went home and I thought about it and I go, I'm only going to get the first question right and then hand it in.
Right.
So they changed the rule the following year that you had to answer all the questions because I realized the first couple of questions were the easiest. So I just answered one, handed it in within 10 seconds. So my correct response divided by, 0.16 was this crazy ratio higher than everybody else who went through and did the standard 60 minutes. Nice. So that kind of thinking, I don't even know where it came from, but as sort of Alice goes, like that's really, it's the creativity of thinking of strategies of even the most inane things like a math contest. It's always been there. And it also helps me think in macro levels is not to buy extended warranties. Also helps me think about like, wow, how many stars are there in the sky can I see? And it's not millions. We can actually only see, I think, 9,092. And we have to divide that by 2 because we're in one part of the hemisphere. Because the naked eye in the most clearest night, we can only see those many stars. And that was a astronomer, I forget her name, because most people think it's millions. No, because of our naked eye, we can only count like a finite number. So it's just a love of numbers. Really, honestly, in a simple, the basic sense, it's a love of numbers.
All right, so I severely paraphrased what you said, and I have this pose to tweet out. I put it in the private chat. Tell me how badly I butchered it and whether or not I can hit send. Sometimes math class is like, hey, let's pretend it's Little House on the Prairie days. Let's live like pioneers. Otherwise, no reason to do this by hand just to find the answer.
That's pretty bang on.
Can I tweet it?
The thing is, the part which is I'm going to push back on, and not push back in a serious way. Little House on the Prairie is my favorite show of all time. Okay, please, that's sacred. Like, that is a sacred show. I love Michael Landon. I love that show from top to bottom. So that's okay. I'm okay with the reference because I still mean it. But just as an aside, that's my favorite show of all time.
I love it. That made me laugh.
I mean, it's true.
Math is funny.
Bring that up. You see this math problem that I put up here. And a student asked me how to do it. So the first thing we said is, well, it's got and that's a 90-degree angle. We should use sine, cosine, tangent. So we did this with the tangent, got a decimal approximation right away. Should be done, right? That's in my mind. This should be done. But of course, it's multiple choice, and they were all in square roots. Why do we do that? Why do we want to answer in square roots, Sunil, other than preciseness out to the infinitesimal decimal place? I'm asking you. I'm starting.
Yeah, for me, so the trig. So when I taught trigonometry, not all the time, but in my final 2 years of teaching, I taught right angle trigonometry without a calculator or a trig table, because I wanted to be all based on estimation. So, for example, I want you to draw any triangle, right angle triangle, and so, for example, okay, you must have access to a calculator. Give me.
It's called my phone.
Huh? Okay. Right here. So sine cos of any angle up to 10,000, I can give you the answer. So put sine cos of any angle. Just tell me the.
Do you mean like sine and cosine at the same time, or
no? Just say like sine of 4,080 degrees. I can tell you the answer for it.
All right. What's the sine of 37 degrees?
Okay. I mean, okay. So basically it's based on estimation. So I'm going to say it's 0.56.
Pretty close. Pretty close. 6018.
Okay. Give me something in the thousand.
All right. Up to 4,000. Is that the?
Up to 10,000, but whatever.
Okay. All right. Then I want 9,999.
Okay. Yeah. Sure, no problem. Okay, so 72, 100, and 36, 360. Okay, so 10,080. Okay. So first of all, I'm going to get the right sign, plus or minus, okay? Because there's a, and I believe 7,200, 3,600, 3,600, 7,200, 360, 260. So it's positive?
It's negative.
Hang on. 9999. Okay, hang on. Can you write 7,200 and oh, I see what I did. Okay, 7,200, 3,600. Okay, so 10,800, 720, and then I got 1 degree. Just give me a second. 90. So okay, so what I'm doing, I'm just going to go. I'm basically rotating around the circle because we know 360 is 1. 3,600 is 10 times. I'm back at 0. Then I'm multiplying 3,600 times 2. That's 7,200. I'm trying to inch my way up to 999. Then if I go another 3,600, that's 10,800. So I've overshot it by 800 degrees. I try to come back. I basically try to get a reference angle between 0 and 90. I try to get the right quadrant. Because I know the sine of 30 degrees is a half, I have these benchmarks of 30, 60, whatever. And then I teach kids this. I teach kids how to estimate, because I don't care that, the tan of 70 degrees is 2.7 whatever. If you can tell me the tan of 70 is about 3 because the opposite side looks like it's about 3 times the length of the adjacent, that to me is good thinking.
Yeah, I agree. I'd rather with what's your thinking. So here's what I did on this one. After I got all the square roots, I said, okay, well, what they're really wanting me to identify here is that this is a 30, 60, 90 triangle.
Right.
Right. And so then I would make a little drawing over here that this is my 60, and it goes, if this is X, this is 2X. And of course, I have to explain to the kid how to use the Pythagorean theorem to derive this X root 3. And so since we're between, and then I realized using X was a bad idea. So then I switch it to M since I had an X already in the problem. We're using the 30-degree angle. So then this is the 2M, and this is the, this is the M square root of 3, right? And this is the M. So if I want to do this, I would do that. No, that didn't, did I do it wrong? I have the 12 in the wrong place. I'm going to redo this.
The 12 is the wrong place?
Yes, because this one already had the answer. If M is 12, then X is 12 root 3.
But the original question was, you were given the angle of 30 degrees and 12 and Y and X?
Yes, but it was like this. So
okay.
Extra evil.
Okay, okay, that's where the 12 was.
Right.
Right.
So,
okay.
So then, right, 12 equals M root of 3, and we divide by the square root of 3. So once I've recognized that this is a 30, 60, 90 triangle, and that I have memorized that it's X, 2X, and X root 3, I know that M is 12 square root of 3 over the square root of 3. And none of those were the answer, and it's the end of class. And I'm like, I know that I did this right. I know these things. And I spent the whole next period trying to figure out what the heck I was doing wrong. And I was writing it out on paper using a pencil, actually, really clear, like, here's why this works. Here's how we take an equal out triangle and cut it up. And here's the pattern we're looking on this. And then it finally dawned on me, oh, right, there's this obsolete idea that you're not allowed to have square root in the denominator.
So hang on. Okay, I'm going to interject because the answers were in decimals, right?
No, the answer has a square root in it.
Okay, so if you go to the question, which is the 30 and the 12, so because it's it's part of your special triangles, and because the way that I've taught trigonometry, it's based on ratio and percentages. Like, think of 0.5 as 50%. Think of 0.86 as 86%. So I know for a fact that X, when the angle is 30 degrees, opposite of hypotenuse gives me a half. I know that my opposite side will be half the length of my hypotenuse. Also, because it's 30 degrees, the cos of 30 degrees is 0.86666, because I know that the adjacent side is going to be, 30 degrees. Okay, you haven't drawn it to scale. So never mind. Yeah, so the cos of 30 is 0.86. So the adjacent side is 86% of my hypotenuse. If I already have 12, then 12 compared to what number gives me about 86%. I don't know, ballpark it. Make it 15. Well, we know 12 divided by 15 is 80%. Okay, make it 12.2. Done. And then
the answer is not a decimal. That was the problem, because I got the decimal like in 2 seconds just using tangent and cosine. So the problem is that the multiple choice has you doing the square root of 3 top and bottom, right?
Got it. Okay.
And of course,
what grade was this?
From pre-calculator days, we don't even teach square roots anymore, Sunil. And that's my favorite conversations is, at some point, we just stopped teaching how to calculate the square root by hand. Like, I'm 44 years old. I have no idea how to calculate the square root by hand. And
well, I think square roots are important. Like, so I try to emphasize square roots. Like, I know in our timetable we go to 12 by 12, which is 144, but you shouldn't have to, like, okay, well, 13, like, you should visualize it's a square. So 13 times 13 is a square, which you've added two 12 by 1 pieces of wood and a 1 by 1 to make it a square. So a 12 plus 1 is 25. 25 plus 144 is 169. Visualize what you're always doing. So I tell kids, you know what? It's a good idea to know your squares, because then you can, again, you have anchors to, if you know that 24 times 24 is 576, then you might have a better chance of what 24 times 22 is or whatever. The more anchors that you have, it just gives you more in your toolbox for that number sense. So I'm a big proponent of squares and square roots.
I have no problem with squares and square roots. I have a problem with rationalizing the denominator. I feel like this is a concept that literally solely exists because of a lack of calculators. So I had the right answer. It's just that because I didn't rationalize the denominator to create an equivalent expression. And so it comes down to, again, is that we ask kids to come up with what's the answer. We want them to find the answer rather than caring more about what's your strategy. Why does this work? What, as you said, you're far more interested in understanding that's 3 times the length, not whether or not it's about 3 because of with some rationalization. I gave the state test recently, and I won't say what was on it because obviously I'm not supposed to, but I was horrified at that. This is what the state of Kansas values in kids knowing.
Well, I would even say that I'm not even sure if they it's almost just like it's a random test for accountability that has no creativity or purpose, but just because it has the authority to give out credentials and stuff, it's just a abuse of institutional power. Definitely. Because if somebody off the street said, "Hey, take a crack at this," it's like the same test. Like, "Hey, tell me how you do on this. Let's go to a coffee shop and have a coffee and you fill this out." You would think this person's crazy. Well, they're not crazy. It's the test which is crazy.
The test is crazy.
And just because it's given out by the institution or whatever, we tend to respect it or revere it without thinking like, this used to be important when we didn't have motor vehicles. Like, forget the notion about falling behind. What are you falling behind in? You're falling behind in Little House on the Prairie stuff.
Right.
Like my kids are learning not because of education, but in spite of it.
Totally.
They're learning in spite of it. They're doing things with their social media and just in terms of the savvy. They're doing what they need to survive and be happy in this world. We're trying to make kids happy and survive a world which no longer fucking exists. There you go. That is your mic drop moment.
That is perfect. And I think what really embodies you, Sunil, is getting that message out that we just live in a world that doesn't exist anymore, and we're just killing the love of math. And we can do better.
It's tragic. Like it's not about like, I mean, if it was like, oh yeah, okay, the stuff we're doing, I can see value in it. Yeah, it once had value. It had value. That's the thing. At a time period for necessity's sake, but I mean, everything has evolved.
I don't take my own paper and I don't shoe my own horses.
Yeah, like we need kids. Like kids they're living in a world through the second and will eventually be third, fourth iteration of social media and all the construct and all this bombardment of data. So we need kids to be able to sift through data. We need kids to analyze data. We need kids to make good choices early on. We don't give them courses or things where they can start to use their what would I do in this situation? How can I make the world better? Like, this is all goofy stuff. It's so benign. It's boring. There's a quote by Alfred North Whitehead, who wrote the 1929 book Aims of Education. He said this actually 100 years ago. He said, inert knowledge, which basically what we still do. And he said this back, 100 years ago. He said, I think I'm paraphrasing, inert knowledge is not only harmful, I mean, but it's dangerous. Like it is it's a very dangerous thing to keep giving kids these buckets of just inert knowledge, which they will never apply, never use, because it robs them of time in which we could do something of benefit.
Totally agree. Totally agree. Well, this was super fun to talk with you today, Sunil. Thanks for taking the time out. And
this is a great way to start a Saturday morning.
It totally is.
Yes.
This is my idea of a good time. I think Melody might have lost her internet or something. So.
I think that might be it, because she's even stopped messaging and stuff.
Yeah. She didn't text me, so I think she lost her internet. But regardless, I certainly enjoyed this, and I appreciate you joining us this morning. And we have many fun more conversations to come.
For sure, we'll continue this.
Absolutely. All right, and bye everybody.
Bye.